Welcome back to my Commodore 64 memories videos. This is where I look at old Commodore 64 software and some of the technical details behind them. Today we have Nigel Mansell World Championship. This was from the excellent Games That Weren't Commodore 64 version of the website. The game was found recently. It was incomplete, of course, because the development was canned before the game was released on the Commodore 64. But we can see some of the excellent history of this game on the Games That Weren't website, and I'll include a link to the website in the video description below. The distribution of this starts off with some nice example music that was never fully integrated into the game because it's incomplete. But it's always nice to have this kind of extra piece to the whole release where we can see what the music was meant to sound like. I think it sounds actually pretty good. There's a few pieces of music in this music demo. So there's that. You can download this from the website and play with it yourself. I'm going to have a look at the game now. So running the game, it seems to do quite a lot of decompressing, and that's because I think it's been one file. The website mentions that the source code, well, PDS source code, the Programmer's Development System source code, was recovered. So I guess that's when it was one file to make it easier to run. Decompressing again, I think. There we go. So, although this game is incomplete, it's actually got quite a lot in here. There's some credits. You can type in your name. You have an option for race a single circuit or full season, improve with Mansell, and you've got music on or off as well. We can see that the selection box, which is flashing merrily away there, is actually a collection of at least 4 different sprites surrounding each of these parts here. The sprites, I think, maybe were even expanded. The course down at the bottom with those red bounding boxes is also displayed as sprites. There's quite a lot of screens here, right? You can set up your car, you can have auto or manual gear shift, you can have hard, soft or wet weather tyres. You can also change your wing angle. We can see there the 4 sprites making up the bounding box of the selection, the square selection or the rectangle selection. I guess it was done like that so they can actually make it a rectangle or more of a square shape. We are, of course, looking at this in C64 Debug GUI. First, we can see where the sprites are on the screen because all of the sprites have red little bounding boxes around them. So we can see, I think, immediately that the wing mirrors, left and right wing mirrors, have some sprites. We can see the course down at the bottom with its flashing flag. It's also made out of sprites. We can see that the steering wheel, I think at least, the hands on the steering wheel and steering wheel perhaps itself is also made out of sprites. The game actually seems to move quite quickly, doesn't it? I think it's pretty obvious that there's raster bars with the grey and green alternating colours scrolling down the screen. I think those are timed raster bars, changing at least probably the background colour or one of the character multicolours. We can see there quite clearly that it's using a double buffered screen because it's shifting between 2 different addresses of C000 and C400 in the screen column there. And also, even though the character set targeting cursor, or the screen targeting cursor, is in the middle of the racetrack, it's alternating between 2 character sets. So, and that's at C800 and D000. So we have those 2 character sets being used and also 2 double buffered screens. As I move the targeting cursor up and down the screen, we can see where the sprites change between the top half and the bottom half of the score display panel and the status display panel. And the game seems to have crashed. Probably because I ran out of time or something like that, because I went into a race. Let's reset the emulator. Whoops. And then let's load it again. Hello again, title screen. We'll try and get past that. There we go. Lots of decompression going on between the Nigel Mansell title screen and then the main game, kind of like this press fire text stuff. It might be a little bit placeholdery, but it looks pretty complete, right? Let's choose race a single circuit again. Let's choose Great Britain, of course. Let's go back into race. I think straight away we'll go into the race. We won't bother to qualify. We can see quite a lot of code being executed in the memory view there in C64 debuggery. So the blue stuff at the top is mostly executing code. The graphics down at the end of the memory are the ones which are being read and mostly written to. So here we are back in the main game view. Well, we can see the car that's coming on from the opponent racing car. It's 2 or 3 sprites being moved around the screen. And don't forget that the targeting cursor is in the middle. So if I change where the targeting cursor is, you can see exactly where the colors for the raster bar splits change there. So that's for the background color and also the color for the side of the racetrack as well. That makes sense. We can see here that we've got a split, so we're using several different character sets, aren't we? So we've got those sprites changing at the bottom as well for the status panel. Wow, there's a lot going on, isn't there? So there's quite a few splits. So we have the sprite splits down at the bottom there, the multiplex sprites. We also have character set changes for the status panel. And we also have a different character set being used for the top of the screen as well. So, wow, okay, cool. Lots of different character sets there. Let's investigate the sides. Well, we know that the character set screen is being used, a multicolor character set screen is being used for the racetrack. And we know that it's having its colors changed with a raster bar effect, raster timed effect. But I'm really intrigued about those wing mirrors, right? Those wing mirrors are also on the side of the screen, but they're below the main racetrack view. They are in the status panel. So the track itself never gets rendered behind those wheels and things like that. But yeah, so look at the wing mirrors. Look, I put the targeting cursor over one of the wing mirror sprites so that we can see the state of the Vic chip at that position on the screen. And we can see here, look, the sprites are pretty plainly showing different sprite frames. And as I move the track left and right, or I don't think it changes. I don't think it renders corners in there. No, it doesn't. It's just a few different sprite frames, and those sprites are alternating between black and white, and we have an alternating pattern to represent the sides of the track. So the wing mirror views are not fully 3D rendered, in inverted commas 3D rendered. They're just basically pre-computed sprite frames, and it's just displaying different sprite frames depending on the road position look. But it is changing between black and white for the sprite color to introduce those alternating black and white sides of the track effects. We can see there as well that the sprites being used for the steering wheel hands are also changing. And because I'm off the side of the road, we've got fully grey and fully green sprites, look, for the wing mirror sprites. So the wing mirror sprites are using 2 sprites overlaid, basically with an alternating pattern. And the sprite colors will be being changed as well, so the pattern will flick between 2 alternating frames. There's no sprite color difference raster timed effect going on there, I don't think. No. Moving the targeting cursor up and down doesn't show any sprite color changes. It's just doing a baked in sprite alternating colors. So you'll notice that one sprite was using black, so that's basically whether or not it's displaying. Let's change all of the sprites so that they're showing in white color. Okay, and now you can see, look, there's either white and black alternating colors, or there's a solid white line as well. So when the sprites are being rendered in the game with alternating black or white, that's where that's where the different stripes of the road get shown. So the game is alternating between black and white there. So one of that black there is going to be transparent, and it's going to show the black behind, right, if you like. And the white line is either going to be black or white, and then the other sprite will be black or white with an alternating color. So yeah, you can quite clearly see how that works there on those two colors there. Look, it's just alternating there, and that's what produces the alternating sprite color for the edge of the road effect in the wing mirrors. But it works really well, right? It's quite simple. It's probably, I don't know, looking at this, it's probably maybe 6 or 8 individual frames, or maybe even 10 or so, for each wing mirror, for the gradient, if you like, or the slope of the line. But yeah, it's a really good effect. So let's have a little look in more detail in the road rendering, right? Because this is what's really intriguing me now, is because it's not a bitmap screen. It's using 2 double buffered multicolor text mode screens with 2 different character sets. So let's have a look at that in ICU. So here we are in ICU 64 sprite view. You can see here, those sprites there are all of the sprite frames, the pre-computed sprite frames for the edges of the track. Top right, we can see the 2 double buffered text screens, and we can also see the 2 character sets. And the character sets are actually dynamically updating. So although there are some static character sets, we've got quite a lot of dynamically updated character set data for each of those character sets as the track changes its view. So if I move the car left and right, or if there's a corner coming up, or if there's a hill. So let's see if we can find where it's storing into that character set with the watch store point command there. This seems to be clearing a character in the character set data with AA, according to this code here. AA is, you know, I always forget which way around the multicolor bits are in the character set data, but AA is either one of the multicolor character colors or it's the character color itself. I always forget which. The only one which is transparent, of course, is 00 in binary. Let's see if we can use the memchar command, the MC command, to look for a track character. And a track character, there we go. So we'll do a watch store point on C8, A8. Let's do that. See where we can trap that code. Okay. So there seems to be some code here which is dynamically updating. Wow, look, okay, so it's, that's intriguing. It's definitely some code which copies from early on in memory. Probably here, right? That looks like trackside pre-computed gradients or something, right? So it's reading, maybe reading what was there previously and then adding on an extra piece of information, maybe. Or maybe I think it's just reading from this, which looks like a pre-computed character set information according to some kind of like gradient calculation or something like that. Maybe it's a perspective. Oh yeah, maybe it's perspective. Although the lines don't seem to get narrower when they go off into the distance, so I don't know. But it's definitely reading from some kind of like organized table information in memory. It's going to be there, roughly in the top left-hand corner of that memory watch point. So look, if I move the car left and right, look, the green area which is being read from that table, look, is, yeah, the green area from that table is definitely shifting around left and right through memory as the car was moving left and right. So it looks like it's related to gradient. Let's look at this dynamic character set update in a little bit more detail by stepping through it, I think. Stepping through the code, I got to this routine, which seems to draw the whole track. So let's clear all of the character set data and all of the screen data, right? So that's going to be from C000 all the way up to D7FF. We'll fill everything with 0. So when we step through the code, or the routines in the code, step over the routines perhaps, we'll see what's being drawn on the screen. So this JSR to 1BBE seems to render a full track view. Okay, so let's step over some stuff and then see where we get to. Okay, so we've got to this routine here, which does some setup, and then it seems to, okay, so it's either running those first 3 JSRs or the second set of 3 JSRs there. So each of these JSRs is probably related to the screen double buffered rendering choice, right? You either render to the first screen and the first character set, or the second screen and the second character set. So let's step over, and okay, it's copying what looks like characters into the character screen, but all of the characters are blank. Oh, there we go. It's that third JSR which seems to render the track. I think the other part of the render was basically the character set copy for the hills and the trees and the buildings in the background, right? So we're not really interested in the scrolling hills and trees and buildings in the background, because that's just, you know, like probably a straight boring character copy, right? What we're really interested in is how the track is rendered. So this routine here, stepping into this a little bit more, seems to be a whole bunch of JSRs which are related to plotting data. There we go. Plotting, starting to plot the edges of the track. As I step over each of these JSRs to 1CF8, look, it's rendering the next batch of next row of pixels into the character set data, and there are what is it, 1, 2, 3, 4, 5, 6, 7, 8 of those JSRs, so that corresponds to 8 rows in a character cell, and then it seems to be, yep, rendering into the next chunk. Well, this is intriguing. So we can see here quite clearly that as it's rendering a new row, it is choosing to allocate some more characters in the dynamic character set information there. Look, so it seems to, look, it's filled in a whole bunch of characters, and then it's gradually introducing the correct track edges as I step over these JSRs to 1CF8. That's intriguing. It seems to have left over a couple of lines of grey, lighter grey colour there in the character set information. So yes, as it is, let's choose the correct character set for the screen view as well. So as it's rendering these rows, we could see that it's, as it's rendering each line, we can see that it's allocating more and more character sets from the dynamic character set as it's moving down the screen. So it renders from far to near, or top to bottom, if you like, on the screen. But yes, it's definitely allocating, kind of like on the fly, but in sequence, new characters as and when it needs it. Well, that's a really good way of doing it. It means that you are creating an optimal set of characters to represent the corners or the sides of the road or the hills or whatever for each view on the screen. I'll just move these over a little bit so that we can see how many steps it's going to go through. So I guess the game knows that there's a theoretical maximum number of characters, perhaps, or a safe limit of characters that it can allocate before it starts going into expected static characters, right? And there we go. So let's clear the whole screen data again. Let's go back to the C800 character set. And then let's run that step over. There we go. Each row, we're rendering each row, and we can see the top left-hand screen there being rendered. We can see from the previously rendered Commodore 64 screen, we can see exactly how sparse the data is, but it's basically filling in the whole line of the text screen, right, the characters on the screen. but we can see that it's not really drawing all of the pixel data for the middle of the track. It's using, or it would be using, a solid pre-computed character, right? Which was at C808 in the character set, or D008 in the other character set. Or maybe it was a clear character. Maybe the first character, the 0 character, was solid, and then the next character was transparent. Maybe it was that way around. I forget what it looked like in the character set layout, but yeah, it was either transparent or solid and then transparent. But yeah, we seem to have here, it seems to be reading from probably some pre-computed gradient table or something like that. Or a lookup table for character cell data or something like that, the address of characters on the screen. Look, here, this load A is from 9899 indirected. So that's reading the current character in the text screen, right? And then it's seeing if it's not equal. If it's not equal, it means that it's something other than 0. And that means that it's found an already allocated character. If it's found an already allocated character, it's going to render updated rows of trackside data into that existing character. Otherwise, it's doing an inc AE and then loading from AE and then storing that into the character screen. So that's basically allocating a new character just by doing a not equal check, or basically a not 0 check, right? That's the way that processor status flags work in the 6502. If you load the accumulator, for example, with 0, then it will be equal, and if you load it with any other value, then it's not equal. So yeah, this basically is a test to see if the intended character position on the screen, on the text screen, already has a character, and if it doesn't, allocate one, and then compute the edge data into the dynamic character set. It's a really good way of doing a row routine. Actually, I really like this. There are other ways of doing it. I mean, you can have pre-computed characters and the gradients and the track edges and all of that in the character set itself, so you don't have to keep on adding new data to it. You can just use pre-computed characters, and I think other character-based racing games, some of them use that method. I know I did in my road racing demo game that I've never really finished. But other games use partial or sparse updates for their dynamic character set updates. Sometimes they use them for roadside objects instead of the track road edges. But yeah, I really like the way that this allocates new characters and renders it from top down. Because you're rendering from top down, you don't need to worry about ORing in the previous row into an existing character. You can just keep on adding new pixel data to the character and doing it that way into the character set data. So I'm just frame advancing here. I'm just seeing how many frames it takes to really render a track view. And wow, it seems to take 1, 2, 3, 4, 5 frames, maybe 6 frames to render each track view before switching to a double buffered screen. But look, let's accelerate off. So, but you can see that the wheels, the car object, and the raster bar timed effects. Look, even though I advance 1 frame at a time, the timed raster bar, or the synchronized raster bar effects for the grey and green and the black and white trackside edges there, they update every frame. So that's really quite clever. I really do like that. That's a really clever road update routine. So it maintains the illusion of updating at 50 frames a second, updating every frame by scrolling the colors down the screen nice and smoothly. But the actual rendered view of the track looks like it's taking 5 or 6 frames to actually render the whole thing. Right, so that's a really good gonna like cheat. I think that cheat would kind of start to fail a little bit with character-based roadside objects. I think it would become more apparent that the frame rate for the actual track render itself is relatively low, 5 or 6 frames. To update the view is actually relatively slow, right? It's 10 or 8 frames a second or something like that, which is not that great. And I think it would become more and more apparent the more trackside objects you have. But with this current rendered view as it is, the illusion generated by the raster bar effects for the color change of the trackside objects, and also the grey and the green grass track area, if you like, that generates a really good illusion of much faster, much more fluid frames per second updates, right? But all in all, really, very, very, very good. Of course, this game demo is work in progress. It was never completed, but I can definitely see from this that there's a lot of potential, and I think with a little bit of extra polish and a few little things added here and there, like sound effects and stuff like that, I think it would have been a really great game, right? I just noticed here what looks like Nigel Mansell's head, and it looks like it tries to speak or animate or talk. There we go, the mouth is moving. So, but that graphic is not being displayed on the screen currently, so I guess that's part of the unfinished game, is we have an animated Nigel Mansell head, I think. It's probably why he's trying to talk to me or something to tell me how to race, right? So yes, if you like these kind of technical deep dive videos, then please do consider liking or subscribing to this channel, or sending me a super thanks. They are always very much appreciated. Take care, have a great day, evening or night, wherever you are.